Hey, I wanted to talk to you about some working in the math program to do problems on section 4.3. There's some that have you use maybe a little different way than you've done some of your other ones. So I wanted to talk you through some of that. Okay, so I am on, where am I? I am on your college algebra assignments, and I'm working some sample problems on section 4.3 with you. All right, so I'm going to preview this and show how it would look if you were working through these problems. Now, I have video examples of most all of these, I believe, in your module, so you can find examples of why the answers are as they are written out, more handwritten out. But I wanted to show you the technology ones, how that looked on your computer screen. So I'm doing this a little differently. All right, so this is what I'm talking about. Starting with your number 4 homework on 4.3, says to graph this function. So it won't let you actually click on this graph and graph it like you may know to do by point plotting, which I like point plotting, and that's probably my base way to do it and for the understanding. But this particular technology doesn't allow you to point plot. So what you do is you pull up this palette and it has you pick which shape you think it is. There's a log shape, okay, and if you hover on it a minute, it'll tell you that is the log tool. And this one is the exponential tool, which you did in the last section, which would also relate to this lesson. So these are inverses of each other, but for right now, we are specifically doing logs. So we'll pick up the log shape. And then the other thing I wanted to tell you is you can't actually point plot, like I said. You might know that the graph is supposed to go through the point 1, 0, but it won't let you control for that. You just click anywhere, click, and it draws it in basic shape. Also note they've scaled this differently. It's not counting by ones. Notice the 50 here. So these are maybe, what is that scaling? How many tickets? 50 divided by 10. So 5, they're counting by 5s. 5, 10, 15, 20, 25. So where I think 1, 0 would be is actually hard to specify because of the calibrations here. But yes, that would be, if we were counting by ones, that would be the point 1, 0. Now notice the vertical scale has counted by ones. That's 1, 2, 3 to get up to 10. So do be aware of scaling sometimes. They don't always count by ones, and that could be confusing. But it didn't matter on this one because the computer was in control of drawing what it considered to be this basic shape anyway. You just pick up the log tool, click, and it does. Then it asks you if you want to use any of the shifting rules, if the graph is correct just as it is, and it actually is. It already has programmed in that the base is 6. That's this subscripted amount. It's a log base 6 of x. So it's already put in there for you. And there's really nothing else that needs to be done. So you don't need to touch anything there. It's correct just as it is. We'll talk about these stretch, shrink, and then shifting rules and reflecting rules, as we'll see in some of the other ones. But this one does not have anything added to it, multiplied on it, no negatives to flip it. Nothing is happening to this graph. So the only thing we did is pick up the log tool, click anywhere, and you were done with that. So just hit save, check your answers. Oops. Check my answer, and all is well. Okay, maybe the next one will be more interesting. So the next one has a shifting. Notice here's, like the last problem, a basic log function. And then the plus 8 we would consider a vertical shifting. So anything that's added or subtracted independently we consider a vertical shift. So it would have a plus 8 on this one. All right, so we pick up our log tool. This one has a parabola and a cube. So just to make sure you know, you are doing a log function and it should look like that shape in standard form. Then again, click wherever you like and it draws it in its standard shape. And this one does show you 1, 0. These are scaled by 1, so a little clearer to see. That's our basic log shape. And normally the pivotal point for a log is at the point 1, 0, and then it increases ever so slightly, but it is going uphill. And then over here, it gets closer and closer to 0. This y-axis is actually an asymptote. It does not touch the y-axis. It just gets infinitely closer to it. But the computer pixels have trouble showing that. And then, like I said, it does have a vertical shift, that plus 8. So make sure you pick shift here, not the stretch. Stretch is when you have a multiplier in front of, like if there was a 5 times that, like with the parabolas. Remember how if you had multipliers in front of the function, it stretched it. vertically stretched it. We usually didn't consider it from the perspective of the horizontal stretching and shrinking, so you can kind of ignore that one for our purposes here. If you have a multiplier in front of it, though, that's vertical stretch. We do not have that here. What we have is a shift. So I move this over to 8 plus 8. Oh, I'll move that little box. 8 places. So it moved it up, vertical shift of 8 places. There's also no reflection. The reflections are when you have negative signs. Just like with the parabola examples, if you put a negative in front of this entire function, it would flip it upside down or across the x-axis. If you put a negative just on the x value there, it flips it across the y-axis. So nothing like that is going on here, only that vertical shift. So we're done with that. And let's see. Good job. It asks about the domain. Let's talk about domain a little bit. The domain is how far it goes left and right. You might remember the x values that are included that have real answers for y. So the x values, they're hovering right at 0, but I know it looks like it in the picture, but theoretically, it never touches 0. So we need to put a parenthesis there and tell I guess we could have picked up the parentheses there. But anyway, we need to tell it at 0. It's very, very close to 0, but not actually touching it. So 0, and then it goes to positive infinity to the right. All right. For the range, it's going up and down without bound. This I know doesn't look like it's going up very far yet, but in theory, it keeps moving, and as it moves, it's also moving upward. So in theory, it would go up to positive infinity. And I am going to use those little things this time. I'm going to go from negative infinity and then to positive infinity. All open. There, if I can get that. Okay. All right. Nice work. It's always good to see that, right? Okay, we talk about 6 in the video examples. You can see more about these other problems in my other videos in your modules. This one you don't have to use the technology. It's just multiple choice. Do you remember that log base 2, if it's greater than 1 base, not a fraction base, but greater than 1 base, then it's going to be pivoting through the point 1, 0 and have this shape to it. So B looks like the correct basic shape. Notice that scaling thing here, because I want it to go through 1, 0, but I see they've got scaling. They're counting by 5s again on the horizontal scaling. But yes, B is the only one that looks like it matches the right shape and direction. Okay, let's see what else we've got. Oh, it wants to know about the domain again. I'm going to go ahead and leave the question, though, because I mainly wanted to talk to you about the technology. I will stop and mention when it's a fraction base, it flips it and comes downhill like this A part. So again, a fraction base makes the log function flip around to where it's coming downhill. It still pivots through 1, 0. It's still that same shape. It's still a log shape. All right, let's find another technology question. Okay, here's another one. I wanted to show you how to do the shifting rules again. So I click on the graph. It won't let me really pick a point. I just have to pick up a tool. I'll pick up the log tool, click anywhere, and it draws it in standard basic form. This is kind of redundant because here's another vertical shift. It's just like the earlier one we did. That's a vertical shift of positive 4. So we go down here, move that over to 4. It moves the graph up 4 places, still the same shape and all. It already has the base 3 listed, so we're done with that. And we move on. I'm not going to do the domain and range parts right now to save time. All right, so here's another thing. This is our horizontal shift I wanted to talk to you about. If it's included with the x, the action of the x in a parenthesis, in an absolute value sign, in a denominator, under a radical with the x, it's included, kind of attached onto the x, the action of the x. Those are our horizontal shifts, and they're always opposite in sign. So this would be a horizontal shift of positive 8. That's all that's going on here. So we click on our graph like we did before, pick up the log tool, and notice because it was a fraction base, it knew to draw it upside down, the decreasing one like I mentioned earlier. But no matter, we don't have to worry about that because the computer does know it's the log shape in standard form. Originally, it goes through the point 10 pivotal point, and then we're asked to use our shifting rules to tell it we know that's a horizontal shift, moving it over positive 8 places. Let's see, I have trouble moving this little thing. Okay, there's 8 places. It already has the base of 1/2. Again, that's the subscript here, the base of the log. It's already in there, and that's the only thing that was going on in that problem. Okay, again, I'm kind of skipping over the domain and range to save time as we talked about that. But no, all the ranges will be up and down without bound in all these graphs. That's true. The range is a give me. Just know that. You should have that in your notes. The range is negative infinity to positive infinity, but the domain may change based on how far it's shifted left or right. All right, here's another one of those horizontal shiftings. You know, it's inside the action of the X. So I pick up my log tool, click anywhere, it draws it in standard form. Because it's a base greater than 1, notice it drew it in this direction as an increasing function through the point 10. We have a horizontal shift again, move it over 2 places. Again, horizontal shifts are opposite in sign, and it already has the base 3 included. Okay, let's see if there's 1 or 2 more like this. Make sure you got it. Oh, that's the one I want to do. Number 20 or number 19. Number 19 has 1 of each. I want to show you that, and we'll wrap up with that one. So it is a log shape. So make sure you pick up your log tool, click anywhere. And then again, horizontals inside the action of the X, but it's opposite sign. So horizontal, I'm moving this back 2 places. And then this is a vertical shift of -3. The vertical shift is -3. I had a colleague that used to say the X is a double crosser and the Y never lies. I thought that was cool. I should give him credit. That's Rick Conley. That's his phrase. The X is a double crosser because it's always the opposite of what it says, and the Y never lies. So the Y shift or the vertical shift is what it says. It never lies. Now notice on this one, it doesn't have the base listed. I have to put that in myself. Unlike the others, the base is that 1/3, but you're seeing that's where that number comes from. Whatever the subscript was is the base. So now we should be good to go. Save, check the answer. All right, I hope that helps you as you work through your homework. As always, let me know if I can help in any way.